Hello students, today I will discuss some typical problems on quadratic equation and complex number. I, on behalf of Aptdemy, Dr. Professor Dr. Vidyut Bodhagupta, will discuss some problems on quadratic equation and complex number. First, I am taking a problem on quadratic equation. The problem is, let PQ with the roots of the equation x squared minus twice x plus a equals to 0 and R and S with the roots of the equation x squared minus 18x plus b equals to 0, and it is given that p less than q less than r less than x are in arithmetic progression. Then order 12ab, that is the value of a and b are these four are given. Which option is correct? So we know that in a quadratic equation, ax squared plus bx plus c equals to 0. The sum of the roots, we remember this thing, sum of the roots equals to minus b by a, and product of the roots equals to c by a. We should use this formula, sum of the roots equal to minus b by a and product of the roots equal to c by a. Now what we are given, p and q are the roots of the equation x squared minus twice x plus a equals to 0. At once we can write p plus q equals to 2 and pq is equal to a. This is the equation number 1 and this is the equation number 2. Again you are given that r and s are the roots of x squared minus 18x plus b equals to 0. So at once you can write r plus s equals to 18. This is equation number 3 and rs is equal to b, equation number 4. Now what do we want and what is given? We are given that p less than q less than r less than s. They are in arithmetic progression. So here the four numbers are given p, q, r, s. They are in AP. So let the numbers be, let the numbers in AP, that is arithmetic progression. What are the numbers? Four numbers in AP. We write in this way: a minus 2d. Next number is our a minus d, and next number r is our a plus d. This is our a plus d, and s is our a plus 3d. You have taken the four numbers in AP as because you are given that P, Q, R, S in AP. So let us write P is equal to a minus 2d, Q is equal to a minus d, R is equal to a plus d, and S is equal to a plus 3d. Now from equation number 1, from 1, you are given that P plus Q equals to 2. So a minus 2d plus a minus d equals to 2. So this will imply twice a minus 4d equals to 2, and this will imply a minus 2d equals to 1. This is the relation number 5. Next, r plus s from 3, r plus s is equal to 18. What is our r? A plus d plus s means a plus 3d equals to 18. This will imply twice a plus 4d equals to 18. This will imply a plus 3d plus 2d equals to 9. This is our equation number 6. Now these two equations solving 5 and 6. Solving 5 and 6. What do you get? Solving 5 and 6, we get a equals to d is equal to 2, a equals to 5, a is equal to 5, and d equals to 2. Yes, what do we want? Capital A and capital B. So we have got A and B. So what is our A? A is our P into Q. So we should find the value of P and Q and also R and S. So PQ is equal to A is equal to from 2 A equals to PQ. What is our P? A minus 3D. What is our Q? A minus D. So this is equal to A minus 3D, that is 5 minus 6, that is minus 1 into A minus D. This is equal to minus 3. So what we have got? This P is equal to, we have got P is equal to A is equal to minus 3. What is our B? From 4, capital A is equal to, we have got capital A is equal to minus 3. From 4, what is our B? B equals to R into S. What is our R? A plus D. A plus D into S. S means A plus 3D. So A plus D into A plus 3D. Put this value. Finally, we'll get the result as 77. So what are the values? You have got A is equal to A equals to minus 3, B equals to 77. What are the options given? Minus 3, 77. So the correct option is, so this order equal AB, this is equal to minus 3, 77. So order equal AB equal to minus 3, 77. Therefore the correct option is, so the correct option is C. So the correct option is C. So we have completed the problem. Next, come to the second problem. What is the problem? We are getting the problem for the equation 3x squared plus px plus 3 equals to 0, where p greater than 0, if one of the root of the equation is square of the other, one of the roots of the equation is square of the other, then the value of p is one of the four a, b, c, d, one of the four options. So what you are given? You are given the equation as 3x squared plus px plus 3 equals to 0. One root is the square of the other. So let alpha and alpha squared be the roots of, say, equation number 1 of the given equation. Let it be the roots of 1. So we have the principal sum of the roots and product of the roots. So let us write sum of the roots, that is alpha plus alpha squared equals to minus p by 3. This is the equation number 2, and alpha into alpha squared equals to 1. This will imply alpha q is equal to 1. Equation number 3. But you want the value of p. How to eliminate alpha? First, you cube equation number 2. Cubing 2, we get alpha plus alpha squared whole cube must be equal to minus p cube by 27. This will imply alpha cube plus alpha to the power 6 plus 3 alpha cube into alpha plus alpha square must be equal to minus p cube by 27. Now this will imply alpha cube is equal to 1. So 1 plus 1, that is 2 plus 3 into what is our alpha plus alpha square? This is our minus p by 3 equals to minus p cube by 27. So after simplification, what do you get? This implies 2 minus p equals to minus p cube by 27. So the equation will come as p cube minus 27p plus 54 equals to 0. Now solve for p, or you can write p square into p minus 3, as the value of p equal to 3 will satisfy this equation. So p minus 3 is a vector plus 3p into p minus 3 minus 18 into p minus 3 equals to 0. This will imply p minus 3 into p square plus 3p minus 18 again you factorize it. This will give 1 factor is p minus 3. So p minus 3 whole square into p plus 6 equals to 0. So what is the values of p? You can take the values minus 3, 6, sorry, 3, 3, 6, 3, 3, 6. So as 3, 3 minus 6. As p greater than 0, as p is greater than 0, we will take the positive value. Therefore, you can write p equals to 3. So what is the correct option? Therefore, the correct option is C. So the correct option that is you are given one root is the square of the other. So let's write the roots are alpha and alpha square. Write down the two equations, sum of the roots and product of the roots. Therefore, we have to eliminate alpha. If I cube the equation 2, what do you get? A cube plus b cube plus 3ab into a plus b. So we can write this as eliminating alpha as p cube minus 27p plus 54 equal to 0, and factorizing it, we have got p minus a whole square into p plus 6 equal to 0. So p equal to 3 or minus 6. As because p, you are given that p is positive, so p must be equal to 3. So the correct option is C. Now, let us come to the third problem. Third problem is if a, b are the roots of the equation x square minus 10cx minus 11t equals to 0, c, d are the roots of the equation x square minus 10ax minus 11b equals to 0. You have to find the value of a plus b plus c plus d where a, b, c, d are distinct numbers. First, we write down the four relations. A, B are the roots of the equation x square minus 10cx minus 11t equals to 0. So you can write a plus b equals to a plus b equals to 10c, equation number 1, and a b is equal to minus 11t. This is our equation number 2. Next, you are given c, d are the roots of this equation, that is c plus d. C plus d is equal to 10a and cd is equal to minus 11b. This is our equation number 4. So look at the equation 1 and 2. So first you add 1 and 2. From 1 and 2, we get a plus b plus c plus d equals to 10 into a plus c. So this will imply c plus d equals to 9 into, this is our 9 into a plus c equals to b plus d. This is our b plus d equals to 9 into a plus c. This is the equation number 5. B plus D equals to 9 into A plus C. This is our equation number 5. Look at equation number 2 and 4. Multiply these two equations. What we get from 2 and 4? From 2 and 4, we get this is equal to 121 into BD. So this will imply AC equal to 121. This is the relation number 6. Now multiply equation number A by 1 by A. Multiply equation number 1 by A and 3 by C and add these two equations. Multiply equation number 1 by A and 3 by C and add these two equations. What you get? We get A squared plus C squared equal to A squared plus C squared minus 11 into B plus D equals to 20 AC. 20 AC equals to 20 into 121, that is 2420. This will imply A squared plus C squared. This will imply A squared plus C squared equals to minus 99 into A plus C equals to 2420. So you can break it up as A plus C whole square, A plus C whole square minus twice AC minus 99 into A plus C equals to 2420. Now factorize it. Let A plus C is equal to, let A plus C equal to X. So what you get, x squared equation as x squared minus 99x minus 2662 equals to 0. From this you can find x is equal to 121. That is A plus C equal to 121. A plus C equal to 121. From equation number 5, from 5, what is our B plus D? What is our B plus D? B plus D is equal to 9 into 121, and that is all 1089. So the value of, therefore, A plus B plus C plus D, this will be equal to 121 plus 1089. The final result is of 121210. So the value of a plus b plus c plus d is equal to 1 to 1 0. Let us go to another problem. If px is equal to ax squared plus bx plus c and qx is equal to minus ax squared plus bx plus c, when ac not equal to 0, then the equation px into qx is equal to 0 has at least 3 real roots, no real root, at least 2 real roots, 2 real and 2 imaginary roots. First we explain when the roots are real and distinct. Suppose you have an equation. Suppose you have an equation ax squared plus bx plus c equals to 0. This quadratic equation you are given. Now what is the discriminant? Discriminant is given by d is equal to b square minus 4ac. What was the theory? If the roots are real and distinct, but if d greater than equal to 0, this implies roots are real. If d is greater than 0, the roots are real and distinct. So roots are real and distinct. If d equals to 0, roots are real and equal. And if d less than 0, roots are imaginary. The roots are imaginary. So in case of the quadratic equation ax square plus bx plus c equal to 0, denote the discriminant d by b square minus 4ac. What is the classification? If d greater than equal to 0, the roots are real, and if in particular d is greater than 0, roots are real and distinct. If d equals to 0, roots are real and equal. And if d is less than 0, the roots are imaginary. These were the conditions. Now what you are given? If px is equal to ax squared plus bx plus c, qx is equal to minus ax squared plus bx plus c, and ac not equal to 0, then px into qx equal to 0 has at least 3 real roots, no real root, at least 2 real roots, 2 real and 2 imaginary roots. How we will discuss this problem? Let us denote the discriminants by d1 and d2. So let d1 and d2, d1 and d2 be the discriminants of px is equal to 0 and qx is equal to 0. the discriminants of this. So what is our d1? Therefore, you can write d1 is equal to b square minus 4ac, and d2 is equal to b square plus 4ac. Now, if you are given if AC greater than 0 and AC less than 0, you have to take this. Why? You are given AC not equal to 0. So AC may be positive or negative. So if AC greater than 0, if AC greater than 0, then D2 is positive. D2 positive means that is the roots of Qx is equal to 0 are real and distinct. Consider the next case. If AC less than 0, but we cannot say in this case, you cannot say D1, the roots of D1 may be positive or may be negative. But the roots of Px is equal to 0 may or may not be real. This was the second case. If AC less than 0, if AC is negative, indicate D1 is positive. D1 is positive means the roots of Px is equal to 0 are real. In this case also, we can say that, but the equation Qx is equal to 0 may or may not have real roots. So what is the conclusion? In both the cases, at least two roots must be real. Now look at the options. At least two roots must be real. Therefore, we can conclude that at least two roots must be real. What is the option? Therefore, the correct option is C. At least two roots are there. Again, I am discussing this problem. First, you find the discriminant of these two equations, Px is equal to 0 and Qx is equal to 0. Let us write the discriminant as d1 equal to b square minus 4ac, d2 is equal to b square plus 4ac. You are given that AC not equal to 0. That means AC may be positive, AC may be negative. First, we consider AC positive In that case, d2 is positive. So the roots of qx equal to 0 are real. Second case, you take AC less than 0. So d1 is positive. That means the roots of ax is equal to 0 are real. So in both the cases, at least two roots. The equation px into qx equal to 0 has at least two roots which are real. And we are given the third option is this. So the correct option is C. Next example, if alpha beta are the roots of the equation x squared plus px plus q equals to 0, and also x to the power twice n plus p to the power n into x to the power n plus q to the power n equals to 0, and if alpha by beta, beta by alpha are the roots of the equation x to the power n plus 1 plus x plus 1 whole to the power n equals to 0, then the value of n, we are given four options, maybe an odd integer, maybe an even integer, any integer, or none of these options. So first look what you are given. Alpha beta are the roots of the equation x squared plus px plus q equal to 0. So at once we can write as alpha beta the roots of as alpha beta are the roots of x squared plus px plus q equals to 0. So we can write therefore alpha plus beta equals to minus p and alpha beta equals to q. Sum of the roots and product of the roots. Again, alpha beta are the roots of the equation x to the power twice n plus p to the power n into x to the power n plus q to the power n equals to 0. So both alpha and beta will satisfy this equation. So again you can write, again we have as alpha is the root of this equation, that is alpha is the root of x to the power twice n plus p to the power n into x to the power n plus q to the power n equals to 0. So it will satisfy this equation, that is alpha to the power twice n plus p to the power n into alpha to the power n plus q to the power n equals to 0. And again beta is the root of this equation, so beta will satisfy this. So beta to the power twice n plus p to the power n into beta to the power n plus q to the power n equals to 0. Now what do you get subtracting these two equations? Subtracting alpha to the power twice n minus beta to the power twice n plus p to the power n into alpha to the power n minus beta to the power n equals to 0. Apply the formula a squared minus b squared and take common. This will imply alpha to the power n minus b to the power beta to the power n into alpha to the power n plus beta to the power n plus p to the power n into alpha to the power n minus, this will imply alpha to the power n minus beta to the power n into now this is not equal to 0 as because in that case alpha equal to beta. So this will imply therefore you can write alpha to the power n plus beta to the power n plus p to the power n equals to 0. That is alpha to the power n plus beta to the power n equals to minus p to the power n. Next, what we are given, if alpha by beta, beta by alpha are the roots of this equation. So as alpha by beta is the root of this equation, so it will satisfy. So we can write as alpha by beta is the root of x to the power n plus 1 plus x plus 1 whole to the power n equals to 0. As alpha by beta is the root of the equation x to the power n plus 1 plus x plus 1 whole to the power n equals to 0. So it will satisfy. Therefore, we can write alpha by beta whole to the power n plus 1 plus alpha by beta plus 1 whole to the power n equals to 0. So this will imply after multiplication by beta to the power n, you can write this as alpha to the power n plus beta to the power n plus alpha plus beta whole to the power n equals to, this equals to 0. Now put this value, what you get? This will imply alpha to the power n plus beta to the power n, what we have got? Minus p to the power n minus p to the power n. And what it is given? Alpha plus beta. Alpha plus beta is our minus p. Put here minus p whole to the power n equals to 0. When this is possible, minus p to the power n and minus p whole to the power n equals to 0. When it is possible, if n is an even number, if n is an even, suppose n equals to 4, what do you get? Minus p to the power 4, then plus minus p whole to the power 4. What do you get? This is equal to minus p to the power 4, then plus p to the power 4. So the above relation is satisfied only when n is even. This will imply n is even. So this relation will be satisfied only when n is even. So what is the option here? Here B is the option. So the correct option is, therefore the correct option, so you can write the correct option. So the correct option is B. First, you are given alpha beta are the roots of x square plus px plus q equal to 0. You can at once write the sum of the roots and the product of the roots. So alpha plus beta, that is equal to minus p, and alpha beta equals to q. Again, you are given alpha beta are the roots of this equation. X to the power twice n plus p to the power n into x to the power n plus q to the power n equals to 0. So both the roots will satisfy this equation. So we have put for x equal to alpha and beta. You have got these two equations, then subtract. Subtracting, and then after factorizing, what we have got, alpha to the power n plus beta to the power n equal to minus p to the power n. Next step, you are given that alpha by beta and beta by alpha are the roots of this equation. So any one of these will satisfy, both the roots will satisfy this equation. I have taken the root as alpha by beta satisfies this equation. So you have put for x alpha by beta, you have got the relation alpha to the power n plus beta to the power n plus alpha plus beta whole to the power n equals to 0. Now put these values, this is minus p whole to the minus p to the power n plus minus p whole to the power n equals to 0. This equality will be satisfied only when n is even. I have taken an example. Suppose n is an even number, so 4. So this relation is satisfied. So the correct option is B. Why? As because n is an even integer. Now come to the chapter on complex number. Chapter on complex numbers. First, just I'm giving the definition and modulus aptitude like this. So, a number that can be written in the form, a number that can be written in the form p plus q, p plus iq, or a plus ib. The number that can be written in the form a plus ib, where a, b are real numbers, a, b are real numbers, and I is an imaginary number. I is an imaginary number. That is I squared equal to minus 1. This number is known as the complex number, and you denote it by z, z equal to a plus ib. So what is the definition of the complex number? A number that can be written in the form a plus ib, where a, b are real and I is imaginary, that is I square equal to minus 1, I equal to 2 whole minus 1, then we say that it is a complex number and denote it by z. So we can write z equal to a plus ib. Now one question will arise, whether minus 2 is a complex number or not. Yes, minus 2 is also a complex number. Minus 2, in case of minus 2, you can write this as minus 2 plus I into 0. And next, whether 3i is a complex number or not. Also, you can write 3i as 0 plus I into 3. Fine. So we can say that every real number is always a complex number and every imaginary number is always a complex number. And what is the imaginary number or what is the real number? In particular, if b equals to 0, that is imaginary point is 0, then this is the real number. This will be real number. If a equals to 0, then we get z equal to ib. This is the imaginary number. So just to define what do you mean by a complex number? The number that can be written in the form a plus ib, where a, b are real, I is an imaginary number, is known as the complex number. And what is the real number? If the imaginary part is 0, then it is the real number, and if the real part is 0, then it is an imaginary number. Now, what is the modulus of a complex number? Mod of z we define is as this is equal to mod z root over of a square del part square plus imaginary part square. This is the modulus of a complex number. Also, another form which is known as the polar form of the complex number, if we write, say, a is equal to r cos theta and b equal to r sin theta, this is the polar form of complex number, b equal to then you can write z as r into cos theta plus I sin theta. This is the polar form of the complex number. Here r is the modulus. And what is the amplitude? You can say that amplitude of the complex number is known as amplitude of z is our tan inverse y by x. And here theta is the amplitude. This is the amplitude. And r is the modulus. In the polar form, so this is the definition of the complex number and their modulus and amplitude. Now I am coming to a problem. Prove that if the ratio z minus I by z minus 1 is purely imaginary. What we have got? When a complex number is purely imaginary, if the real part is 0. So if the ratio z minus I by z minus 1 is purely imaginary, then the complex number z lies on the circle whose center is at the point half into 1 plus I and radius 1 by root 2. Now another modern definition of the complex number is ordered pair of real numbers is a complex number. Another modern definition is ordered pair of real numbers. Ordered pair of real numbers is a complex number. Suppose you have an ordered pair -2, 3. What does it represent? It represents the complex number z equal to -2 plus 3i. It represents the complex number -2 plus 3i. So this is a Helps definition. Simple, just ordered pair of real numbers is a complex number. Now here you are given that prove that if the ratio z minus I with z minus 1 is purely binary, that means this complex number has the real part 0. Then you will show that z lies on this circle whose center is at the point half into 1 plus I and radius equal to 1 by root 2. So let us write let z equal to x plus iy. Now simplify it. Z minus I. Now z minus I by z minus 1. This is equal to what is our z minus I? X plus iy minus I by x plus iy minus 1. So this is equal to, here part is our x, imaginary part here I into y minus 1, and this is our x minus 1 plus iy. How to put in the form a plus ib? You rationalize it. Denominator, you have x minus 1 into x minus 1 plus iy. So how to rationalize? Corresponding minus factor, x plus I into y minus 1 into x minus 1 minus iy. So as to put in the denominator as a square minus b square in this formula. So you can write this as a square minus b square. As because I square equals to 1, we can write this as x minus 1 whole square plus y square. Now collect the real part. If you multiply x with x minus 1, this is one real part. Whenever we multiply I into I minus 1 with minus I y, minus I square means plus 1, that is plus y into y minus 1, this upon x minus 1 whole square plus y square. Then put the imaginary part I into, here the denominator is x minus 1 whole square plus y square, and I into, so this multiplied by x minus 1 multiplied by y minus 1. Next portion is minus xy. Now what is given? This complex number is purely binary. So by the problem, this real part is 0. So we can write x into real part is 0 means x minus x into x minus 1 plus y into y minus 1 equals to 0. Real part by the problem, real part is 0. This is by the problem, real part is 0. Simplify it. This will give x minus half whole square plus y minus half whole square equals to half, that is 1 by root 2 whole square. Why I have written this equation in this form? We know that if a circle has centered alpha beta, if a circle has centered alpha beta and radius r, then what's this equation? This equation radius r, its equation will be x minus alpha whole square plus y minus beta whole square equals to r square. So from here we can write that this represents a circle whose center is, what is the center? Center is half in the real plane. Whose center is half. And what is the radius? Radius equal to 1 by root 2. Half means the center is half in the real plane. Just now I told you ordered pair of real numbers is a complex number. So this is the center. This center is in the real plane. You can write this is the real plane. So what is in the complex plane? Half plus half I. This is in the complex plane. So you can write this as half into 1 plus I. So the center is half into this and radius is 1 by root 2. What we have done? You are given that a complex number z minus I, but z minus 1 is purely imaginary. Just from the beginning I have told you the complex number is purely imaginary when the real part is 0. So first you convert the complex number in the form a plus ib. So let us write z equal to x plus iy, and after rationalizing we have put in the form a plus ib. So the real part must be equal to 0, that is x into x minus 1 plus y into y minus 1. This is equal to 0. From this we can write x minus half whole square plus y minus half whole square equals to 1 by root 2 whole square. So this represents a circle whose center is at the point half in the real plane, that is half plus half I, that is half into 1 plus I in the complex plane, and radius is 1 by root 2. Next we take the second example, a value of theta for which the complex number 2 plus 3i sin theta by 1 minus 2i sin theta is purely imaginary is 5ac, 5ac and inversely by root 3 by 4, sin inverse 1 by root 3. This complex number is purely imaginary, you are given. So first you put in the form a plus ib. 2 plus you are given you are given 2 plus 3i sin theta by 1 minus 2i sin theta. Just like it. This is equal to this is equal to 2 real part plus write the real part. This multiplied by this minus 6i square. That means minus plus 6i square means minus 6 sin theta by 1 plus 4 sin square theta. 2 minus 6 sin theta, 6 sin square theta, not sin theta, by 1 plus 4 sin square theta plus I into. When this multiplied by this, that is 3 sin theta plus the imaginary part, plus the imaginary 3 sin theta plus 4 sin theta. 1, 2 plus ci, the 7 sin theta y, 2 plus ci sin theta, 1 plus 2i sin theta, plus 3 sin theta plus 4 sin theta, plus 4 sin theta. This part 2 multiplied by 2. Here part imaginary part is when this multiplied by this and this multiplied by this. 3 sin theta plus 2 sin theta. This is our 2 into 2, 4 sin theta. This upon 1 plus 4 sin square theta. So the complete form is 2 minus 6 sin square theta by 1 plus 4 sin square theta, 7 sin theta by 1 plus 4 sin square theta. This is in the form a plus ib. What is given? Purely binary. Just now I told you, if it is purely binary, so real part must be 0. So you can write by the problem, the real part must be 0. So 2 minus 6 sin square theta equals to 0. This will imply sin square theta equal to 1/3. This will imply sin theta equals to plus minus 1 by root 3. So theta equals to sin inverse plus minus 1 by root 3. So this is our plus minus sin inverse 1 by root 3. So the correct option is D. For the given options, the correct option is D. Just put in the form A plus IB. So the real part 0 will get theta is equal to sin inverse plus minus sin inverse 1 by root 3. So we want the value of theta. So this D is the correct option. So the correct option is D. Next, another problem. If Z1 and Z2, and Z2 are complex numbers such that real part of Z1 equals to mod Z1 minus 1, real part of Z2 equals to mod of Z2 minus 1, argument, that is the amplitude of Z1 minus Z2 equals to 5 by 6, then we have to find the imaginary part of Z1 plus Z2. So let us take the two complex numbers as that Z1 equals to, let us write Z1 equals to x1 plus iy1 and Z2 equals to iy2. What is the real part in the first case? This is the real part. In case of the complex number Z1, real part is x1, imaginary part is y1. In case of complex number Z2, real part x2 and imaginary part y2. So from this you can write, therefore you can write real part of Z1, this is our x1, and real part of Z2, this is our x2. Real part of Z1 is our x1 and real part of Z2 are x2. And what is the complex number? Z1 minus 1. First we write now Z1 minus 1, that is our x1 plus iy1 minus 1. This is equal to x1 minus 1 and plus iy1. And what is our z2 minus 1? Z2 minus 1 equals to x2 plus iy2 minus 1, and this is our x2 minus 1 plus iy2. We have transformed the complex numbers z1 minus 1 as x1 minus 1 plus iy1 and z2 minus 1 as x2 minus 1 plus iy2. What will be their modulus? We know that if a complex number is of the form z equal to x plus iy, then what is our modulus of z? The modulus of z is nothing but this is positive square root of real part square and the imaginary part square. So mod of z1 minus 1, you can at once write, therefore mod of z1 minus 1 equals to root over x1 minus 1 this whole square plus y1 square, and mod of z2 minus 1 root over of x2 minus 1 whole square plus y2 square. what you are given? Real part of z1 equals to the mod of z1 minus 1. So we can write by the problem real part of z1 is our x1 equals to mod of z1 minus 1, that is 2 over of x1 minus 1 whole square plus y1 square. So this we can write as x1 square is equal to x1 minus 1 whole square plus y1 square, x1 square minus 2x1 plus 1 plus y1 square. From this you can write y1 square is equal to y1 square is equal to 2x1 minus 1. Similarly, from the second relation, what you can write? Similarly, from the second one, relation, we get y2 square equals to 2x2 minus 1. Subtract these two. Y1 square minus y2 square equals to 2 into x1 minus x2. So therefore, a plus b, take it off, a plus b, j minus b. So we can write y1 minus y2 by x1 minus x2 equals to 2 by y1 plus y2. This is the relation number 1. Next, argument of z1 minus z2 is equal to pi by 6. Argument of z1 minus z2 means, that means you are given tan inverse argument of z1 minus z2, argument z1 minus z2 equals to pi by 6. This will imply tan inverse, that is tan inverse y1 minus y2. Argument means amplitude, taking tan inverse y by x. So we can write tan inverse y1 minus y2 by x1 minus x2 equal to pi by 6. So from this you can write y1 minus y2 by x1 minus x2 equals to tan pi by 6 1 by 2 3. This is the relation number 2. What do you want? Imaginary part of z1 plus z2. So what is our z1 plus z2? z1 plus z2 equals to x1 plus x2 plus I into y1 plus y2. So imaginary part of y1 plus y2, from this we get imaginary part of 2 by y1 minus y2 by x1 minus x2. So imaginary part of this z1 plus z2, we can write this as z1 plus z2 equals to y1 plus y2 equals to y1 plus y2. Here we have got y1 plus y2 is equal to 2y, this y1 plus y2, this y1 minus y2, y1 minus x2, from 2, this y1 plus y2, you can write this as 2 root 3. From where? We have got it from relation number 1 and 2. From 1 and 2, y1 minus y2 by x1 minus x2 is equal to x1 2 by y1 plus y2. So from 1, this is from you can write from 1 and 2. From these two relations, you have got y1 plus y2 equal to 2 plus root 2 root 3. So what is the option? So the correct option is D. Therefore, the correct option, so D is the answer. First, you are given del part of z1 equal to mod of z1 minus 1. That form you have got this equation. Similarly for the second, then subtract these two, we'll get the value of y1 minus y2 by x1 minus x2. Put this value in equation number 2. You have got 2 by y1 plus y2 is equal to, from 2, put here 2 by y1 plus y2 is equal to 1 by root 3. So y1 plus y2 is equal to 2 root 3 from 1 and 2. This is from 1 and 2. I have written here as because from 1 and 2, y1 plus y2 equals to 2 root 3. So the correct option is D. The last example is the imaginary part of 3 plus 2 root over minus 54 whole to the power half. That is square root of this minus 3 minus 2 root over minus 54 whole to the power half can be one of these four. So the imaginary part of this. So first, to put let x is equal to the whole number, this whole to the power half and this whole to the power half minus this whole to the power half. So let us write let x is equal to let x is equal to 2 minus 3 plus 6 root 6 I whole to the power half minus 3 minus 2 into 3 minus, similarly this will be 6 root 6 I whole to the power half. How it comes? 2 into root over minus 54. That means 2 into minus 9 into 6. That is 6 into root over minus 6. This is nothing but 6 root 6 I. And that's why I have written let x is equal to 3 plus 6 root 6 I whole to the power half minus 3 minus 6 root 6 I whole to the power half. Now square both sides. Squaring both sides, what you get? X squared equals to a minus b whole square. First a squared, delete the square root, then plus b squared, then minus 2ab minus 2 into a into b. That means 3 plus 6 root 6i into 3 minus 6 root 6i a square plus b square minus 2ab, 2 into a into b. So what do you get? This is equal to, so x squared is equal to, that is our 3 plus 3, this is our 6, minus 2 into 9 plus 216 whole to the power half. This we can write as 6 minus 30, and this is equal to minus 24. Therefore, x is equal to, x equals to plus minus root over minus 24. That is equal to plus minus therefore, imaginary part x means this expression. What is our x? The total expression. Therefore, imaginary part of x. Therefore, imaginary part equals to this is the imaginary part. So, what is the option? Therefore, you are given the correct option. So, the correct option is B. So, the correct option is B. What do you want? The imaginary part of this is one of these four. So we have taken x as this, squaring both sides. What you have got? Minus 24, x equal to plus minus this, plus minus. Imaginary part just, now I have told you, if a complex number is of the form a plus ib, so what is the imaginary part? When the real part is 0, imaginary part is nothing but y. So imaginary part is equal to y. So the imaginary part is 2 root 6. Now, one more example I am giving you for your home task. That means after these problems, one I am giving you only one problem for quadratic equation. You try to solve it. It's a very interesting problem. You are given ABC are the sides of a scalar triangle, and if the equation is has the real and distinct roots, then the value of lambda is one of this. I am giving the hints of this problem, how to proceed. Look at the problem. You are given the roots of this equation as real and distinct. And just now I told you that if the roots of a quadratic equation, roots are real and distinct, what is the result? Real and distinct means roots of the quadratic equation. We have got d, real and distinct means d greater than 0. So you can write at once the discriminant. First you proceed in this way, d greater than 0. Not real and equal, real and distinct. From this you will get, here the equation is, so from this, do it at home, this will, you will proceed this d greater than 0. From this you will get a square plus b square, a square plus b square plus c square. This is greater than 3 lambda minus 2. We will get 3 lambda minus 2 into AB plus BC plus CA. AB plus BC plus CA. We will get this result from this. And at once you can write 3 lambda minus 2. This is less than a square plus b square plus c square. We will proceed in this way by AB plus BC plus C. I am giving you hints. We'll solve this problem. First you proceed this way. Now, what you are given next? The ABC are the lengths of scalene triangle. You know that in a triangle, sum of any two sides is greater than the third side. That is, say A plus B greater than C, B plus C greater than A, C plus A greater than B. From these relations, you can write at once A greater than C minus B, B greater than A minus C, and C greater than B minus A. Squaring and adding, what you get? From this, you will get A square plus B square plus C square. Will get squaring and adding, you will get this as A square plus B square plus C square. This is equal to, this is greater than 2 into A square plus B square plus C square minus 2 into AB plus BC plus CA. First relation we got this as the equation number 1, and from this relation we will get another relation. This will imply that is 2 into AB plus BC plus CA, 2 into AB plus BC plus CA. This is greater than A square plus B square plus C square. This is our relation number 2. From these two, we get the value of lambda. But you get from 1 and 2, you get this lambda is less than 4 by 3. How will we get lambda is less than 4 by 3? So, we'll try. I will give it hints most of the easiest problem. Totally. We'll try to solve it. Thank you. This is all I will discuss today. I'll finish here. Thank you.